Hello students. Here I am going to discuss one more problem on change of integral into polar coordinate, that is the concept of change of variable. I hope you have seen the previous lecture. So continuing the same, I am just solving one more question for changing it into polar coordinate. As you remember that in polar coordinate, we are having substitution that x should be replaced by x equals to r cos theta and y should be replaced by what? X equals to r sin theta. Moreover, the value of Jacobian that we have find is r. That is dx dy will also replace by r dr d theta. I'm writing these things directly from the previous lecture because we have done discussion that why the Jacobian is r in polar coordinate. So now let us see how this integral will be look like after changing it into polar coordinate. As we have discussed that by changing the variable means what? We are changing the region of integration. Now I'm just writing the new region as r dash. The new region as r dash. X, we are having x equals to r cos theta. So put the value of x, then root over x square plus y square, that is r square cos square theta plus r square sin square theta into Jacobian, which is, I am just writing firstly Jacobian, then dr d theta. This is how the integral will look like after changing it into polar coordinate, which will be equals to integral over r dash. This is what r square can be taken common. So it will be cos square theta plus sin square theta, which is 1. And under root of r square is r only. Jacobian is r into dr d theta. This r got cancelled. So it will equals to integral over r dash r cos theta into dr d theta. The integral from xy plane changed into r theta plane. But one thing is left here, that we need to find the new region of integration for finding the limits of this integral. For that, we need to use the given region, that is the given limit. You can see the limit of y. The limit of y is given y equal to 0 to y is equals to root over 2x minus x square, and the limit of x is 0 to 2. Limit of x is given as x equal to 0 to x equal to 2. If I solve this much, this is what? Doing the squaring on both sides. So x square plus y square minus 2x equal to 0. So this is the reason, student, which will be formulated in xy plane. If you see, this is what? A equation of circle. Equation of circle. Standard equation is what? X square plus y square plus 2gx plus 2fy plus c equals to 0. If I do the comparison of this circle by this equation, why I am doing the comparison? Because I need to draw this region. And for drawing a circle, I need the center as well as radius of the circle, which can be evaluated by the comparison. So I'm getting G as -1, F as 0, and C also 0. So center of the circle will be what? Minus G comma minus F. That is, center of this circle is 1 comma 0 and radius is 1. How the radius is 1? Because we are having G square plus F square minus C. Why I am doing these things? Because I need to draw the region in xy plane so that I can draw the corresponding region. So this is a circle whose center is 1 comma 0 and radius is 1. Means what? This will look like how? a center, a circle whose center is 1 comma 0, like this, radius is 1, so this will be look like something this. A circle, this is what a circle we are having. I am just drawing it again in a more appropriate manner. So the circle is what? Once again, this is a circle whose center is 1 comma 0, whose center is 1. This is how the region look like. The name of this equation is x square plus y square minus 2x equal to 0. This is the name of this circle. Now why I'm drawing only the half part? Because you can see x is moving 0 to 2 and y is started from 0. That is, this is the line y equal to 0 na? So I have to take only the upper half. This is x equal to 0 and this is x equal to 2. So this is the required region in xy plane. The same if I convert in polar coordinate will also look like same, but the equation will change. If I convert this equation by putting x equals to r cos theta, y is equals to r sin theta, what I will get? R square cos square theta plus r square sin square theta minus 2r cos theta equal to 0. R square can be taken from these two terms. So sin square theta plus cos square theta is 1. So this is r square, this is minus 2r cos theta, that is r can be taken common. This will be r minus 2 cos theta, which is what? R equals to 2 cos theta. That is the equation of circle from xy coordinate, which is x square plus y square minus 2x equal to 0, will converted by r equals to 2 cos theta. Means this is what look like this, and its name is what? R equals to 2 cos theta. This is x equal to 0 and x equal to 0 means what? R cos theta equals to 0. That is theta equals to how much? Pi by 2. So this line will be theta equals to pi by 2. Y equal to 0 means theta equals to 0. This is the reason in r theta plane, students. Now in order to find the limit, I just take the strip like this, an elementary strip. Now let us see what will be the limit we are having. You can see the value of r over here is 0 because x is 0, y is 0. So r equal to 0, 2 terminated on this curve, which is 2 cos theta. So r equals to 0 to 2 cos theta. What about theta? The rotation of this strip, you will see the rotation of this strip is started from x-axis to here. The rotation of this strip inside the region is like this, like this. This is theta 0, this is theta pi by 2. So theta will be 0 to pi by 2. So these are the new limit for the given integral. So now put the limit in the integral which we are having over here. So this will be what, students? Theta, not theta, r equals to 0 to 2 cos theta, and y, r is done. Now theta equals to 0 to pi by 2. Inside r cos theta dr d theta. Now do the integration and we will get the result of the given integral. I left this solution for your practice. Firstly, we should do for r, then put the limit, then for theta. So this is how, students, we have changed this integral from xy coordinate to polar coordinate. Hope you understood the concept.